All right, welcome. We're going to talk today. Lesson 1-7 is going to talk about midpoints and bisectors. And I would say here in understanding, let's see, today's goals, as we find the coordinate of a midpoint on a number line, that's going to be one formula that we're going to use. Finding the coordinates of the midpoint or endpoint of a line segment on the coordinate plane. Again, that's going to be a formula that we use. And then finding missing values using the definition of a segment bisector. So here, beginning with these formulas, we want to make sure that we understand the formulas so we know what they're asking us and how to use the formulas. And then as we talk about the segment and bisector, we're going to really talk about midpoint. Bisector means we cut something in half. When we bisect something, we make two equal parts. Well, if we make equal parts, then that by definition means they're equal to each other. So we're going to be doing a lot of using those terms to create formulas and work with. So let's see here, starting with the midpoints on a number line. The midpoint of a segment is the point halfway between the endpoints. The point is equidistant from the other points if it is the same distance from them. So thinking about one-to-one, if I take the midpoint of something here, M, if it's the midpoint of AB, then this portion is equal to this portion. That's what they say when it's one-to-one ratio, because it's split it into two equal parts. So here, as we talk about midpoint on a formula line, if AB has endpoints x1 and x2, x1 and x2, on a number line, then the midpoints M of AB is the coordinates. M is going to be one coordinate plus the other coordinate divided by 2, 1/2. Okay, so, I'm sorry, when I say 1/2, dividing by 2 is like multiplying by 1/2. So looking at that formula, understanding that I have a starting point, I have an ending point, and I have the point in between. Okay, so finding the midpoint on a number line. What is the midpoint of xz? Well, x, -3, z, 8. So here I have x1, x2. They did some substitution. The midpoint is equal to x1 plus x2 divided by 2. So 8 plus a -3 divided by 2 is going to equal 5/2 or 2.5. So the midpoint of xz is 2.5. Approximately right there, 2.5. If we were to look at it and do some counting, let's see, I am 1, 2, 3, 4, 5.5. 1, 2, 3, 4, 5.5. So yeah, those two portions look the same. So we are 5.5 the distance between the two, just sort of counting it out. So ratios. Remembering that one-to-one refers to the ratio of the distances, not the measures of the segment. And then here, would our answer have been different had we reversed our x and y? Sorry, x1, x2. And if we did, let's see, we would have come up with, that would have been -3 plus 8 divided by 2. Well, thankfully, when it comes to when it comes to adding and subtracting, order does not matter. Take that back. When it comes to adding and multiplication, order does not matter. Subtracting and division, order matters. So in this case, it would not have affected our answer because we would have come up with the same answer. All right, so moving on. Check. Let's see, remember my midpoint is equal to x1 plus x2 divided by 2. So what is the midpoint of AF? x1 x2, so my midpoint is equal to -5 plus 7 divided by 2, which is going to be 2 divided by 2, or 1. There's my midpoint right there, 1. And of course, you could probably count this one out. It's not a fraction, so it's a little bit easier to see. Okay, so let's see here. How else? Oh, sorry, a pony, apony, not sure. Works at, again, we're using these real world concepts. We're trying to apply geometric formulas and terms and images into real world problems. So she works at a vintage clothing store, and she wants to hang a new sign so it is centered above the dressing room doors. Centered above the dressing room doors. Given that the dressing room doors have the same width, okay, so those are equal, find the point along the wall that she should hang the new sign. So we are trying to find this point right here. This point right here. Right there. That's what I'm thinking. How am I going to do that? And they've come up with some stuff, but if we just think about a number line, if I take the corner of the wall and I say that, hey, that is 0, 0, and then I travel over here, and then this is 7.5 feet, and this is 13.5 feet, because those are my distances. I can maybe think of that then, okay, so it looks like the door is somewhere between 13.5, 7.5 and 13.5, and since these doors are the same, they said they're the same width, I want to find the halfway point between there, because that's where I want to hang the sign. And that's what they did. That's how they came up with this formula, or that's how they came up with the information. They said, okay, halfway between these two numbers, there is my x1, my x2. So they just plug those in, and they said when they added those two things together, I think they came up with 21 over 2, which is also the same thing as 10.5. So Apony should hang the sign 10.5 feet from the left side of the wall. So there we go. We sort of used some of our mathematical information in geometry and came up with an image, used the number line, and was able to use our formula. Okay, on this check, Jorge travels from his school, Escuela, on 38th Street to the library on 62nd Street. So the library, I think, is that Biblioteca? I'm not sure. 62nd Street. So he stops halfway to take a break. Where does Jorge stop to rest? So we have a starting point. We have a x1. We have a stopping point, x2. And we're trying to figure out somewhere in between. So the midpoint is going to be, again, x1 plus x2 divided by 2, which is nothing more than this. One of my values was 38. The other value was 62 divided by 2. The midpoint is going to be 100 divided by 2, or 100 half, which is 50. So here is my halfway point, 50th Street. Jorge stops at 50th Street. Okay, so there you go. Doesn't take a lot. We just have to filter through the information they give us. Okay, so as we talk about the coordinate plane, though, now we don't just have one line. We have two lines, right? We have a y-axis, our y-axis, and our x-axis. So again, we're just going to be able to calculate the distance between the two, because we're going to have what will be, what I like to say is our x midpoint and our y midpoint that we are calculating. So we just have to really do that midpoint formula twice for my x coordinates and my y coordinates. And that's what they're showing us here. All right. That's what they're showing us here. X1, X2, that was what we did before, but then we also have this vertical height using our Y values. So that's the only difference. And again, midpoint formula, yeah, you guys should have been doing this before. This isn't anything new like the distance formula. It's just a matter of brushing off the dust and working with it. So finding the midpoints on the coordinate plane, find the coordinates of M, the midpoint of AB, if A is -2, 1, and B is 8, 3. So not drawing a scale in any way, shape, or form, but here it is, the midpoint between A and B. I'm looking to find point M, and then we just took our X1, X2 values. We have -2 plus 8 divided by 2, and then we have our Y value, 1 plus 3 divided by 2, and those simplify down to 6/2 and 4/2, or also 3/2. So my midpoint, I'm sorry, not 3/2, but 3/2. My midpoint is 3/2. So just being able to do that, it didn't matter, understanding, knew what my endpoints were. So here it says, find the coordinates of B, the midpoint of AC. Okay, again, AC, I'm looking for my midpoint. A is -3, -2. C is 5 and 10. So I'm just going to use those coordinates to come up with my midpoint. So using my coordinates, x1 plus x2 divided by 2, y1 plus y2 divided by 2, substitute in my values, and I came up with 2/2, or also known as 1, 8/2, also known as 4. So there's my coordinates. B should be 1, 4, which is my midpoint, 1, 4. So let's see, moving on to another couple of examples. Let's see here, finding the missing coordinates. Now, think of using the midpoint formula is just simply finding the missing value of the midpoint, okay? So in this case, sometimes we may be given the midpoint, we're trying to find out some other missing value. So always, we're finding out a missing value. Okay, so find the coordinates of A if P is the midpoint of AB. Okay, and just thinking about this, I'm going to draw this picture of what they're giving us. Midpoint of AB, so here's AB, and they given the midpoint of P, which is 3 and 1/2. B has a coordinate of 8, 3. And this is the coordinate we're trying to find, x1, y1. That's the coordinate we're missing. So we have an x2, y2, we have a midpoint of x, and we have a midpoint of y. So we just use that information they've given us and do some substitution. So with this, the midpoint is equal to the midpoint formula. And I just broke it down that I understand the x value can be an individual problem on its own, the y value can be an individual problem on its own, and then work with that. So that's what they've done here. X1, Y1, they said my x midpoint is equal to x1 plus x2 divided by 2. So doing some inverse operations, let's see. Looks like they multiplied both sides by 2 here to get rid of our fraction. So 3 times 2 is 6. Then you would go ahead and subtract 8 from both sides. So it turns out that x1 is going to be -2. Okay, -2. Doing the same thing with my y values. The midpoint of my y value was 1. I'm sorry, 1/2. The y1 we don't know. Y2 is 3 divided by 2. That's my formula. Again, multiplying by 2 on both sides. That is going to be 2 times 1/2 is 1. Subtracting 3 from both sides. And then y1 turns out to be -2. So there you go. The coordinates that we came up with A are -2, -2. Okay. Then it says plot the coordinates on the coordinate plane and check your answers for reasonableness. Okay, if B, I went ahead and have plotted these points a little bit for you, B and P. So thinking about that reasonableness of it, that is one of my segments, and if this is my midpoint, it's my midpoint, right? I should extend over this direction somewhere too. So is -2, -2 reasonable? It's reasonable looking at it that I know that I am going down here into my negative values, and this is negative values this direction. So both of my values are going to both be negative. That is reasonable. So just thinking about that, and turns out that this is -2, -2. That's my A value. I could look at it mathematically and say, hey, how far am I away? How far did my slope go? Right, I traveled 1, 2, 3, 4, 5 to get here. So then I could turn around and do the same thing. I could go 1, 2, 3, 4, 5, and know then that my X value should fall right there. I could turn around and say my Y value, how far down did I travel? I traveled 1, 2.5. Well, if I travel 2.5 again, 1, 2.5, that would be the visually calculating where my numbers appear. So just keep that in mind, that it did seem reasonable. I was able to graph it out. I was able to plot it, measure it, those kind of things. I could have also calculated the distance, right? I could have used that point and this point, calculated the distance and said, do those 2 points equal? You know, is this distance, using the distance formula, equal to this distance? I could do that, but that's a lot of work. Knowing that calculating the midpoint properly, I did not need to go back and check that. So using this, I will just say, I will give you a minute. Go ahead and do this check that we're doing in class. Check, find the coordinates of Q if R. Find the coordinates of Q if R is the midpoint, right? There's R. Here's Q. And I'm doing this just to make my X1, Y1, and then S is going to be 12, 4. That way I'm getting in the habit of using the same, looking for X1, and then plugging that into my formulas and coming up with my missing coordinates. So those, of course, would be my two formulas that I would use to come up with my missing endpoints. And again, multiplying both sides times 2. I have 12 is equal to x1 plus 12, subtracting 12 from both sides. My x1 value is equal to 0. And then doing the same thing, formula for my y value. I multiply both sides by 2. I have -2 is equal to y1 plus 4, subtract 4 from both sides. And then y1 is equal to -6. And so I have 0. Let's see here, Q should be 0, -6. And if I'm not going to put it on the graph, I could, but if I just do some mathematical thinking, okay? Mathematical thinking, if I look at my X value, I traveled, in order to get from 12 to 6, I traveled 6 units on my X values. So that means I should travel another 6 units on my X values to get to the other end of my segment, which would be 0. My Y values, I moved from 4 to -1, which is actually a distance of 5. So if I traveled a distance on my y-axis another 5 in that direction, I should end up going -5, so that would be -6. So those, I can look at that and say, hey, that seems accurate. If you are not in that position yet to be able to calculate that, not a big deal. Some people would look at that and say, hey, I understand that process, but being able to use our formulas here, that's the big thing. Bisectors, again, as I continue with this, and we talk about a midpoint bisects something in half, and understanding a segment bisector means that the two pieces are going to be equal to each other. And if they're equal to each other, we learn that they're congruent. If they're congruent, we can make them equal to each other and solve. So just understanding what does bisect means, it means we have a midpoint, means two things are equal. So here, finding the missing measurements, find the measure of RT. Well, in order to find the measurement, I need to figure out what in the heck x equals. And they told me that t is the midpoint of RQ. So I'll just turn around and say, hey, RT is equal to TQ. Then I did some substitution and substituted in the value 2x plus 3 for RT, 4x minus 5 for TQ. I went ahead and subtracted 2x from both sides to combine my variables. So I have 3 is equal to 2x minus 5. I add 5 to both sides to get my variables by itself. So 2x is equal to 8. Dividing both sides by the coefficient, and x is going to be equal to 4. They did not ask me for the value of x. They asked me for the measure of RT. So in order to find RT, I needed to take and substitute in the value of x. So 2 times 4 is equal to 3, or RT is equal to the length of 11. Okay. So using that information, we're going to, well, hold on. This says, is there a way to find the length of TQ without calculating when you know the length of RT? If I know the length of RT, could I calculate the length of TQ? Absolutely, because they're equal. But anyway, find the measure of RS if S is the midpoint. That's what I needed to know. If S is the midpoint, then S bisects RT, and those two things are equal to each other. Other things I know that those two things, that betweenness, they would add up to the full length. But if we look at this, we're trying to find RS. So if I make those two things equal to each other, we can come up with a missing value. So if I substitute in the value of RS is equal to the value of ST, I then continued to combine like terms, 6x minus 6x is 0. If I minus 6x from one side, I have to do it to the other. So 7x minus 6x is 1x. 1x, or x minus 5 is equal to 4. I add 5 to both sides, and I get x is equal to 4. They didn't ask me for x, though. They wanted me to find the measure of RS. So RS is 7x, or 7 times 9 minus 5 is equal to 63 minus 5, which is 58. So there you go. Understanding those definitions allows us to find out information utilizing. And then last, we have a couple of more examples here. Not a big deal. Finding the total length. Okay, find the measure of AC if B is the midpoint of AC. Again, if B is the midpoint, that means those two things are equal to each other. So I can take AB and make it equal to BC. Did my substitution. I start combining like terms. I end up and determine out that x is equal to 4. Okay, great. Did they ask me for x? No, they asked me for AC. So I turn around and can do two things. I can add these two up, right? Add those two up to find out what AC is. So that's what they did. They said AB plus BC is equal to AC. So substituting in my value of x. Let's see here. I end up with 20 minus 3 plus 8 plus 9. So I have 17. Gosh, that is, I want to say 34, right? So the measure of AC is going to be 34 units. And that is how you do that. I could have also just calculated, thinking about it, if those two things are equal, I could have calculated one segment and just multiplied it times 2, because that is the definition of bisector, 2 equal parts. And then here it says find the measure of AC if B is the midpoint. So I know, again, that AB is equal to BC. So I can do some inverse operations. Okay, so this is the kind of problem that immediately throws students for a loop because it came out to a fraction, and that immediately makes things more difficult sometimes. But knowing that AB is equal to BC, because B is a midpoint. Then I can make AB equal to BC, do some inverse operations, and end up, let's see here, subtracting 3m from both sides. I have 4 is equal to 5m plus 3, subtract 7 from both sides. Again, getting 5m by itself is equal to 3, negative 3, sorry. Divide both sides by 5, and m is equal to negative 3 over 5. Immediately, fraction, negative, But if you substitute it back in, right? 3 times negative 3/5 plus 4 is 11 over 5. And then 8 times negative 3/5 plus 7 is also 11 over 5. So that we know we worked it out correctly. So you could say 11 over 5 plus 11 over 5 tells me what AC is equal to, which is 22 over 5, which is the same thing as 4 2/5, or 4.4. Another way to look at that is you could have just said 11 over 5 times 2 is 22 over 10. Okay, so again, let me fix that. 22 over 5, which is 4 2/5, or 4.4. So there you go. Coming up with a length for AC. So there is using my midpoint and bisector. And again, these are kind of terms that are going to come back all the time, because when we bisect something, that means we have congruent segments, which means we can make them equal to each other. And there's just tons of different things that we will utilize with those vocabulary over this entire course. So good luck, and we'll work on today's assignment.